All right, let's talk about the graphing review. We start off with a ramp sketch here, and this car is on a flat surface, and it's going to go away or forward from the motion detector, because our motion detector is our origin. So if that's the case, if we move away from things, we're going to say that away is forward, oops, and towards is in reverse. If that's the case, then this is a positive direction and this is a negative direction. So the distance versus time graph, what we can say about the slope is that it is positive because it's moving forward or away, that it is linear or constant because it's a straight line, and that it is the slope of this graph, a distance versus time graph, always tells me velocity. If we had to think about this in real life, this would be cruise control. All right. So because we said this was positive over here and it's going forward, that's going to make this in quadrant 1. But we said that it was also constant, so that means that this is going to be just a horizontally flat line, and that wasn't a really good line. Let's redraw that on that. Okay. So that's a better one. Okay, a horizontally flat line in quadrant 1. The slope of this graph we can say is 0, and that it is also a constant. And the slope of a velocity versus time graph tells me acceleration. So if that's the case, this has 0 acceleration and it has a positive velocity because it's going forward, but it's going forward at a constant speed. Okay. When we move to the next one, we have it going on an incline now, and the motion detector is at the top. So again, it is moving away from it. Since it's moving away from it, that's going to be a positive value. It is not constant this time. This time, since it is going down the ramp, it is going to be increasing. And again, this is velocity. So this is a positive velocity, but it is increasing or changing. Okay, so when we come over to our velocity versus time graph, again, because A is positive, this has to be in quadrant 1. And because B says it's increasing, this has to have a slope. Since it's increasing, that means it's going to be a positive slope. So it would look like this. So when we describe this slope, it is positive, it is increasing, and it is acceleration. So positive acceleration in quadrant 1 means that it is increasing. Let's move on. This next one, I still have the motion detector at the top, but now it's going towards it. Because it's going towards it, we're going to say that it is a negative. All right. Now, oops, the bell's ringing this morning. It's 7 o'clock. All right, so we have a downward curve instead, and that downward curve means that our speed is decreasing. And again, this tells me velocity on a distance versus time graph. So I am going to be in, since I have negative as the first set of information over here, that's going to make this one in quadrant 4 because directional information on this graph is told by the quadrants. So in quadrant 4, if I did this in quadrant 1 and it was decreasing, it would look like this. So I told you when you think about doing this in quadrant 4 to just reflect it across the x-axis. So this would need to look like this. Now the slope of this line is positive, and it is not a constant speed, but it is linear. So we could say that it's linear because it's a constant acceleration rate. And then for C, we could say that this is acceleration. Now, this would get classified. This would get classified as positive acceleration, but positive acceleration in a negative quadrant actually means that it is slowing down. Okay, so remember, positive acceleration, negative quadrant means it is slowing down. All right, now we've changed where the location of the motion detector is, and the motion detector is now at the bottom. All right, because the motion detector is at the bottom, this is going towards it. Okay, so since it's going towards it, we say it's a negative direction. But as it goes down the ramp, it is actually going to be increasing. So that's why it's a curve, because it's not remaining constant. And this is velocity. All right. So again, because this is negative here, this has to be in quadrant 4 when we draw this. If we drew increasing in quadrant 1, it would look like this. So now we're going to reflect it across the x-axis and we'll draw a line that looks like that. This has a negative slope. It is still a constant acceleration rate because it's a straight line. So it is a constant acceleration rate and it is acceleration. Now, a negative acceleration in a negative quadrant means that it is speeding up because two negatives make a positive. So it's really important to think about what it does in quadrant 1 and then just flip it across the x-axis. All right. All right, for this next one, we have the motion detector at the bottom and the car is going up the ramp. So if we talk about directional information, it is going away, so it's going forward. So this is going to be a positive. Oops, I don't want to use red, I want to use blue. Okay, so this is a positive. Now, if we think about this curve, it's eventually going to go like that. So this is decreasing, and this is velocity. Remember, positive velocity just means it's directional information, but it's decreasing because it's a curve, and so it is actually changing. When we come over here to our velocity versus time graph, though, we're in the positive quadrant, so we're going positive, so that's in quadrant 1. We're decreasing, so this needs to have a negative slope. So that's going to be negative slope. It is constant still, though, because acceleration rates are always constant because they're a linear line. And this is going to be acceleration, because the slope of a velocity versus time graph is acceleration, but negative acceleration means this is slowing down. Okay, in quadrant 1. My next one, I don't have a distance versus time graph, but I do have a velocity versus time graph. So let's think about this. If this is in quadrant 4, it is, let's just talk about its slope first. So its slope is negative. Oops, wrong color. It is negative. It is constant, in meaning that it has a constant acceleration rate, and it is acceleration. But if we look at this, it's in quadrant 4, so a negative acceleration in a negative quadrant should mean that this is speeding up. All right, so if that's the case, over here, as it comes down the ramp towards it, we are going to need to say that it's coming towards, so it's negative slope, and it's going to be increasing. because negative and negative means it's speeding up, so that's increasing, and this is velocity. Because we said it's increasing, that means it's going to be a curve, and because we said it's negative, that means it's going to curve down like that. All right. So it is important that you realize you can make a lot of predictions about one graph or the other in both directions. Okay. All right. This one looks a little different because it looks like we have two trips. So on this one, we're going away from the motion detector first because we're doing this part first, and then we're coming back this way. So if that's the case, we're going away first, so that's positive and negative, because right here, that has a velocity of 0 because its distance stays the same, and so distance and time, it doesn't change. So that's going to be a velocity of 0 right there. So it's switching directions right there. It is first going to go away, so it's going to decrease. So it decreases and increases, and this is velocity. So as it goes up the ramp, it decreases velocity, but as it goes back down the ramp, it increases velocity. So if we want to start off in a positive direction, we're going to start off in quadrant 1, and then we have to move to quadrant 4. So we're going to decrease while we're in quadrant 1. Right here, my velocity equals 0. It switches directions, and it continues there. So I end up with a negative slope and a negative slope still. It is still constant though because my acceleration rates are constant, and this is acceleration. So it is slowing down, changing directions, and then speeding up. Because a negative acceleration in a negative quadrant is going to make it positive. All right. For this next one, I've now just moved where the motion detector was. So we've now gone ahead and said that we went towards it first. So we went negative and then we went positive because we went towards it and then away from it. As we were going towards it, we were decreasing. And as we went away from it, we were increasing velocity. Again, it's 0 right here. Our velocity is 0. So this time we're going to want to start in quadrant 4 and move into quadrant 1. So if that's the case, I have to draw my line like this because it is a positive slope and a positive slope. I have a constant acceleration still rate, and this is acceleration. But I have a positive acceleration in a negative quadrant, so that means it's slowing down again, changing directions. The triangle means change direction, and then speeding up. All right. If you have more questions about this, feel free to come see me, but make sure that you also know how to use your calculator and graph. Okay? Good luck on your exam.